Students, I'm your Kusum ma'am. Let's start with important laws of your physics. So here, the first one, it is from light chapter, the law of reflection of light. So the first law states, angle of incidence is equal to angle of reflection. That is, angle of incidence, which is represented by I, is equal to angle of reflection, which is represented by R. Now the second law states, the incident ray, reflected ray and the normal to the mirror at the point of incidence all lies on the same plane. If we come across the law, here incident ray, reflected ray and normal all lies at the same plane. So the second law. Now the next important law of this chapter, the law of refraction of light. The first law states the incident ray, the refracted ray and the normal to the interface of two transparent media at the point of incidence all lies on the same plane. So if you remember, refraction, we need two medium. One is rarer and other is denser. When light travels from one medium to another, it will either bend towards or away. So here the incident ray, reflected ray and normal all lies at the point of interface. That is first law. Now the second law, ratio of sine of angle of incidence to sine of angle of refraction is a constant for the light of a given color and for the given pair of media. So this law is also known as Snell's law. So sometimes they can ask for one mark question, state Snell's law, where I is angle of incidence and R is angle of refraction. Now here sine of I to sine of R gives a constant which is called refractive index and is represented by mu. Now let's start with the third law. It is from electricity chapter, so it is Ohm's law. Ohm's law states that the potential difference V across the ends of a given metallic wire in an electric circuit is directly proportional to the current. That is, potential difference is directly proportional to current. V is proportional to I. Flowing through it provided its temperature remains constant. Okay, when the temperature is constant, V is proportional to I. To remove this proportional sign, we use constant R. V is equal to IR. Thus, R is V upon I. R is constant which is called resistance. Now the next law, this is also from the same chapter, Joule's law of heating. So if you remember, in my previous video, I explained how to remember the law, that is heat generated after PT. And power is very important. Thus it is VIRT. Now, as per Ohm's law, V is IR. Finally, H is equal to I square RT. Thus, we can state the law as follows. Heat produced in the resistor is, so heat produced is directly proportional to square of current. Here we are getting I square. So, heat produced in a resistor is directly proportional to the square of current. That is first point. Now, we'll further add heat produced is proportional to resistance. That is directly proportional to resistance for a given current. And again, it is proportional to temperature, proportional to time. So directly proportional to time for which the current flows through the resistor. So when we are writing, we need to state the law in three steps. First, heat produced is directly proportional to square of current, is directly proportional to resistance, and is directly proportional to time. So this is Joule's law. Next one is right hand thumb rule. This is from magnetism chapter. When the right hand grips the conductor with the thumb pointing in the direction of the current. So we need to hold the conductor in our right hand such that our thumb gives the direction of the current. Then this wrapped fingers will give the direction of the magnetic field lines. So here the thumb is representing current and the fingers are giving the magnetic field. So the law, when the right hand grips the conductor with the thumb pointing the direction of the current, the wrapped fingers will give the direction of the magnetic field lines. This law is also known as Maxwell's corkscrew rule. So sometimes they can ask by making the name like Maxwell's corkscrew rule, which is another name for the same rule. It suggests that if you imagine driving a corkscrew in the direction of the current, suppose we are driving a screw in the direction of the current, then the rotation of the corkscrew represents the direction of the magnetic field. This rotation will give the direction of the magnetic field. Now the sixth law, which is Fleming's left-hand rule. Now this rule states that this rule is used to determine the direction of the force on the current carrying conductor in the magnetic field. They can ask one mark question. Which law is used to find out direction of the current or the magnetic field? We need to write Fleming's left-hand rule. So the law states that stretch the thumb, forefinger and the middle finger of the right hand mutually perpendicular to each other. So we need to stretch out three fingers, that is thumb, forefinger and middle finger perpendicular to each other. If the forefinger points the direction of the magnetic field, there the forefinger will give the direction of the magnetic field, the middle finger will give the direction of the current, whereas the thumb will give the direction of the force in the conductor. Now the last one, seventh law, which is Fleming's right hand rule. Again in the same way, stretch the thumb, forefinger and the central finger. So this is forefinger and the central finger of the right hand mutually perpendicular to each other. Like the previous case, this is related to right hand. If the forefinger points the direction of the magnetic field, thumb the direction of the motion of the conductor, and middle finger points the direction of the current induced in the conductor. So here the word induced is used. You need to concentrate on that. So these are few important laws of your physics. Definitely one is going to be asked in your exam. So hope that everyone will prepare it thoroughly. So let's have a short recall. If we stretch out the three fingers, this is for the left hand rule. Forefinger will give the direction of the magnetic field. Middle one will give the direction of the current. And thumb will give the motion of the conductor for the left hand rule. For the right hand rule. And for the left hand rule, forefinger is giving direction of the magnetic field. Middle finger is giving direction of the current. And thumb is giving the force of the conductor. So all of you please prepare this thoroughly to represent in your board exam.